program tool 6. It's now time to insert our drill can cycle. So to do that, it'll be insert F3, F5 can cycle, F1 drill, and we have, this is nothing new. You guys have programmed this exact same toolpath already previously. Drill a bolt hole circle, drill an array, which is what we used before, or drill repeat, which is just repeating one you've already programmed. We're just going to use drill. Same questions that asked before. Are we going to do a chip break, a deep drill? Deep hole or chip? Okay, drilling, deep hole, chip break. Drilling, it goes straight to depth. No pause and no nothing. Deep hole, the tool's going to drill as far as you program it, full retraction to pull chips out. Drill another depth, full retraction, which is what you guys were using that had coolant. I recommend you keep using that if you have coolant. Chip break is when it's just going to pause. Now, what am I programming here? What's right, but what feature am I making? I'm making a spot drill. How deep am I going to go? Well, we're going to get to that in a minute, but not very, right? We're just going to use the tip in just for a second. So, in this case, we're going to go straight drill. Roger that. Here, the position, where am I going to drill? What is going to be my location? 0. 0, because us, being the lazy machinists we are, and knowing that we're prone to make mistakes, we put the work coordinate system where our feature needs to be made. Surface height is also at 0. We're not going to be doing any facing here. Clearance height, this is when you need to move between features. It's going to come up to 100 thou. Rapid to depth. Now, this, when we are proving out our programs and we are single blocking, and I tell you to stop an inch away from your part and feed hold so we can check distance to go, when I do that, we are heading to where this location that we programmed. We can program this at all different places. We could program this at 1 inch. So your tool's heading to 1 inch, and we can just single block it and check our distance to go there. The problem with that is it's going to start drilling from 1 inch away. Okay, feeding really slow. So that's no good. All right, depth. I recommend we do not drill 1 inch into our part with our spot drill. Now, I'm going to have to do a little bit of math. I know. Especially triangle math. You like triangle math? They only had a name for that type of math. There you go, trigonometry. Front of the class, you. All right, so what diameter am I spotting to? 0.28. Good. And I'm using see if I can do it. Which way do I want to do this? Right here. I'm using my 90-degree drill to spot 0.28. See if I can help us out a little bit. All right, maybe there. Can't quite see. So, I'm going to trace this tool for the purpose of illustration. So there is my 90-degree spot drill. I'm going to split that spot drill in half, because this drill, since it is rotating, is going to machine just like we do on the lathe, where anything we do to one half the part is repeated on the other. Okay? So, what I want to do here is I want to draw a line at a simulated 0.28. If I can see if I can get that situated for you in your orientation. 0.28 inches. So the question is, boys and girls, what is this axial distance to give me a 0.28 diameter? So what we do is we break this in half, and we use this right triangle right here. Where this leg, what is this leg right here? One half. Say again? 140 thou. Yep, 140 thou. Okay, you can do this, Damon. Now, this being a 90-degree spot tool makes this a right triangle. So if this is 140, what's this one? 140. How deep am I going to drill? 140. Everybody good with that? Roger that. Let's go back to our computer and program it. So my depth is 0.14. Wasn't that simple? Plunge rate. What is plunge rate? It's been on all of our toolpaths so far. It's a feed in Z. Remember, we are rapiding to 100 thou above our part, G00, as fast as it can go. After that, we're going to feed. And this is where we put that feed rate in. So, what do we need to know to program a feed rate? Okay, do we know the RPM? Do we really? Who told you the RPM? No one. We already programmed the RPM, didn't we? At 1364. Piece of cake. That's a known value. What's the next thing in our feed rate? Number of flutes. Do we know what that is? It's 2. Still don't have to work at it. It's super easy. So what's going to be the hard part? Chip load. I'm going to give you the chip load. What did I use for the chip load on this? Let's use 1.5 thou. 1.5 thou. As I switch screens, it's always going back to that. So, use that calculator. See, it hasn't given me brain damage yet, so you can use it too. Math. 1364 times 2, enter, times 0.0015. Is that right? Is that passing a sniff check? It is 1364 times 2. Gives me 27. Yep. Okay. So, 4. All right. Now this is one we haven't messed with yet. Dwell time. Dwell time. We're going to use my high-tech training aids here. I wonder if I can do that on the other side. Not that one. There we go. Oh, look at us. Okay, my next high-tech training guide. So our RPM, so here we go. Dwell is expressed in seconds. Okay? So why would I need to dwell? Glad you asked that question. When you're operating a CNC machine, a drill is going to feed until it hits its Z depth, and it's going to retract. It's not even going to make one full revolution at the bottom of that feature. When we were doing through holes, that was cool. We didn't need it to. We're poking through. Here we're not. We actually want to leave that conical shape in our part. So I want to do at least one revolution at the bottom of this hole. So I need to know how long to plan the dwell in seconds. So we got to do some of that cool math that you guys learned and never got to use it in any life situation here. We're going to convert units. So the unit we're starting with is RPM, revolutions per minute. Well, I don't want minutes, I want seconds. So how do I convert minutes to seconds? Divide by 60. Is that what you, oh, you're just looking, you guys actually seeing it. Roger that. At least you're saying it. So we divide it by 60. And that gives us how many revolutions in a second. So right now we are getting 22 revolutions per second. So if I do a 1 second dwell, I'm going to get 22 revolutions. Do I want that?
No, you want 1 revolution.
Okay, well, what's wrong with 22?
Too many.
Okay, that's good. Anybody put a point on that, why it's too many? What's it going to happen?
Heat up your tool.
It's going to create heat. That's all it's going to do. Once it does 1 revolution, I'm creating heat. So let's not do 1 second. So I want to dwell for 1 revolution. Anybody know how to do that?
You do 360.
I do, see if we can get my fat hands out of here. We do 1 revolution divided by 22. Let's go back up to the screen and we can see the monitor. It makes sense because I showed you. So 1 revolution divided by 22. 0.045 seconds is 1 revolution. Okay? So that's going to be our dwell. 0.045. And hit accept.